Today on Capechi's Corner, we're going to learn how to interpret graphs. We're going to look at circle, line, and bar graphs, as well as histograms. We are first going to look at circle graphs, and when we're looking at a circle, the whole percentage would equal 100%. So we're breaking it down a little bit. 50% would be half of a circle. 25% is a quarter, and if you keep breaking it up, then we have a 12.5% and a 12.5%, which together equals 25. Now, if we're looking for a percent, we're going to take apart however many students or items we're talking about divided by the whole number of participants or items we're talking about. If we see the word of, we know we're going to multiply. And if we're talking about something that says out of, if we see that phrase that says out of, that means we have to divide. Now remember, a percentage of any whole will equal the part, and we'll look at some examples. The circle graph here represents the favorite dessert of the 4th grade class. So if we look, we see we have lots of options. We have candy, we have ice cream, cake, and cookies. And the numbers show the number of students that answered this response. So how many students took the survey? We'll add all those responses together, the number of people, and we have 371. What percentage of students like cake? Well, this we're going to take the part, which is going to be our cake, 112, over 371, which is the whole, which is the number of people that took the survey, and we get about 30%. In question 3, it says what percent of students like candy or ice cream? So we're going to have to take candy and ice cream, add those values together, and we get 174. Divide that again by our total participants is 371, and we have about 47% said they like candy or ice cream. Line graphs are useful in showing trends in data over a period of time. So I have a data collection in a table, which definitely gives me some information, but if I display it in a line graph, I'm able to see how the trends are going in a little bit better fashion. I can see that Chad's hat is increasing, and I can even, now again, I gather this data through 2002, and if I wanted to predict it at the time, I could kind of see that the trend would keep going. Now, this multiple choice question is a little bit different in that we're not asking to come up with values. The question just says which question cannot be answered by looking at the graph. So we have Michael's math average, and we have the months from September through January, and it looks like his average is pretty good. It goes anywhere between the 70s up into the 90s. So let's see what questions we have below, what some of our answers are. So letter A says, which months did Michael have an average of 85% or better? We can tell that by looking at our graph. We can come up with all the months in which 85% or better, so we can see that. Letter B says, what's the difference between Michael's best and worst month? We could definitely do that. It looks like his best month was September and his worst month was December, so if I wanted to calculate, I could do that. Letter C says, what caused Michael's math average to drop below 80% in December? Now here's the thing, from the line graph, we can see that December is definitely the lowest month of Michael's math average, but I don't know what the cause is. So I'm going to say that does not look like that's going to be something I can answer from the graph. But like we've talked about before, in multiple choice questions, it's always good to look at all the answers before we just kind of jump to one that we think is okay. So let's look at letter D. What is the mean, which is the average, of Michael's math average from September through January? We could find that as well. We could get each of his math averages and come up with an average for that time period. So that is also something that looks like we could tell. So the original question said, what question cannot be answered by looking at the graph? So that would be letter C. Our next question says, based on the line graph, which statement is true? So let's look at the graph. We have the average rainfall in Erie, Pennsylvania. We have our months listed down here, and the rainfall in inches is on the left-hand side. So let's see which statement is true. Letter A says rainfall increased each month. Well, that's not true. It does increase for a while, but then there's a dip here, and there's another dip here, and another dip here, so that's false. So we're going to write false because we want to look at all of our options before we jump to one we think is correct. And let's look at the next one. The next one says the amount of rainfall was about the same in May and July. So this is May here, and that's July there. That looks true. So I don't want to just say that that's it. I want to look at C and D. In letter C, it says the greatest amount of rainfall occurred in June. Well, it looked like the greatest rainfall actually occurred in September, so that one's false. And letter D says the amount of rainfall was the same in January and July. So here's January, and here's July. So that's definitely not true. That one's false. So if we go back to our original, we're asking for a true statement. We only have one true statement, so our answer is letter B. Our next type of graph is a bar graph, and we use that to compare amounts. We have a vertical bar graph listed here, but we can have it horizontal as well. In our table, we have the number of coins, we have the type of coins, penny, nickel, dime, and quarter, and how many we have in our coin collection. And to give us a better visual, we have it displayed as a bar graph. So I can clearly see from here that I have a lot of pennies. My nickels is not as many, but it's pretty close to my quarters. I can answer questions such as how many dimes do I have, and for my bar graph it looks about 130. So the bar graph is a nice way to display data. In this example, we have Australian expenditures on pet care for 1 year. And if we have to interpret our bar graph, we have to realize we have dogs, we have cats, and we have others. This is the Australian states, and this is cost in millions of dollars in 1 year. So we have actually a few bar graphs in each state, so we have to pay attention to the key that we're given right here. Number 1 says which two states had about the same amount of money on the other care for pets. And that looks about the WA and the SA, those states, they're the abbreviations, those states look about the same for the other category. And in number 2, it says, what is the approximate total expenditures on dog and cat care in the state of SA, that abbreviation. So it looks like our dog is right here. And that looks about, we can say about 140. And when we're looking at our cat, we could say that looks about 80. Again, we're approximating. So when I add those together, I get 220. And that is $220 million because we have to pay attention to what our information states on the bar graph. Our last type of graph from today is a histogram. So what a histogram is, it's a type of bar graph, but in this case it's showing continuous data. So there are a few characteristics that we have. The bars in a histogram are always vertical, and they're also always connected. So if you can see in the histogram, there's not a space between the bars are connected. And the horizontal axis is labeled using intervals, a lot of times with time. So we can take our information from the table, and another way to display it is through a histogram. Now in this histogram I can see that most of the movie downloads occurred between 4 o'clock and 6:59. I can also ask specific questions such as how many movies were downloaded between 11 and 11:59, and that looks like it's about 11 or 12. So again, just another way to display data. Let's look at the last question for today. It says, which histogram represents the frequency table above? So we're talking about the number of sit-ups students can do in 1 minute. So right here we have our first row is the number of sit-ups that they can do, and frequency would be how many people were able to hit that goal. So we need to find first, probably the easiest way, you can just start anywhere. I'm going to start all the way on the right. So I should have 40 plus should be my last number of sit-ups. So let's take a look at each example one at a time. In letter A, I have a frequency goes from 0 to 13. That looks pretty good. My number of sit-ups so far, I have the right bars. I have 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 48 plus. So that looks like it's labeled correctly. Again, I had circled, I want to take a look at how many people could do 40 plus sit-ups, and that's 2. So that one looks okay. So far, letter A seems okay. In letter B, we have the number of sit-ups, but we're not using the right labels here. This has a frequency instead of the actual number, so that one's not going to work. In letter C, again, our labels aren't right. We have frequency at the bottom and the number of sit-ups up the side, and the number of sit-ups only goes up to 13, and in our table, the number of sit-ups goes to 40 plus, so that one doesn't look like it's going to work. In letter D, Again, we have frequency 2 to 10, and we have our number of sit-ups. So again, this one's not labeled correctly either, so that one doesn't look very good. So just to make sure that we're okay, I'm going to go back to letter A and just kind of make sure each of them match up correctly. So I have the number of sit-ups 0 to 9, looks like it's 10, which matches my table at the top. Number of sit-ups that were 10 to 19, it looks like I have 8 people can do that, so that looks good. If I go into the 20 to 29 category, that looks right. That's at 9, which matches my table. Number of sit-ups 30 to 39 in a minute is 6. And that also looks like that matches my table. And the last one, which we had checked originally, is 2 people can do 40 plus sit-ups, and that looks good. So I'm going to say letter A is the histogram that represents the frequency table.